Hello everyone, welcome to another video from Btech. So today the topic is from multiple integrals. Here as I have written, line integrals, surface integrals and volume integrals usually confuse students who learn this calculus. Okay, so I thought of giving you a different way of learning all these three, a comparative study with these three. Also I will give you the diagrammatic meaning of all these three. Also will give you an idea how to solve the questions based on these three. So let's start the video. So let's begin with drawing the Cartesian coordinate system. And I am going to explain this line integrals. For that, I am going to draw a function f. Okay. So I can take three line integrals for this function. That is integral f dx or integral f dy or integral f dz. Just see what I am going to do. That is, for integral f dx, you have to look the function from this position. That means your left side must have origin with you and your right hand side should have the positive x-axis. Okay. So while looking from here, you can see a projection of this function, isn't it? This function will be having a three-dimensional movement, but still if you look at from this side, you can have a projection of this particular function. And the area of this projection with this x-axis is what you get from integral f dx. Okay. So actually this is the area of the particular function with respect to this xy plane. Okay. So while looking from here, you can see this shape as a different one. So the area of that shape is integral f dx. Okay. Now what is integral f dy? So now you have to stand in front of this, so that your left hand side will have the origin and the right hand side will have the positive y-axis. Okay. So while looking from this end, you can see the function making this much area with respect to this 0 y-axis. So the area of this violet color shading gives you integral f dy. Okay. Now last one is integral f dz. For that, where you have to stand is over here. So this left side becomes your origin and right side becomes your positive z axis, isn't it? So while looking from that end to this function, while you look at this function, what you get is the area of this function with respect to this z axis. One thing you have to make sure is that whatever lines you draw from the curve should be perpendicular ones and not the slanting lines to these axes. Okay, just draw perpendicular lines and get the area of that particular shape. Okay, so all these three is got from these three line integrals. Okay, now let's move on to the surface integrals. Surface integral, for surface integral actually we are having somewhat surface. Okay, now we can get okay, let's name this as, here also we can have three double integrals or three surface integrals, that is f dx dy or double integral f dy dz, lastly double integral f dx dz. Okay. Now what does this dx dy indicates? Actually you have to project this sheet, this area over to this xy plane. Now we are taking dx dy, isn't it? So you have to project this area to this xy plane. So you get a shadow over here. So actually this area is got from taking the double integral of f dx dy. Okay. Now for double integral dy dz means you can guess that is, you have to take the projection over to this YZ plane. YZ plane is just the screen behind, isn't it? So actually it would come like something like this. So the area under that sheet, area of that projection is got from double integral f dy dz, and lastly it is double integral dx dz, that is in this xz plane you have to take the projection. Okay. So this projection's area is got by taking the double integral for the function in dx dz plane. Okay. So that's it. And finally for volume integral, it does not have that much explanation, because your function will be a solid shape, something that contains a volume. Okay. So triple integral, we only have one integral for this, that is triple integral this function dx dy dz. So actually what we get from here is simply the volume of this particular shape. Okay. So now take some problems and try doing all these three. So here is the question. Evaluate f of xy equal to xy along the curve x square plus y square equal to 1 from 0, 1 to 1, 0. So actually here two functions are given. One is xy, another one is x square plus y square equal to 1. Let's see what all are there. Let me start with the same xy coordinate system. And it said that we have to evaluate this along the curve x square plus y square equal to 1. What is this function? This represents a circle with center 0, 0 and radius is 1. Because we know that x minus h whole square plus y minus k the whole square equal to r square is a circle with center h comma k and radius r. So by comparing, it is 0, 0 is the center and it is a circle coming. Also, since this circle has the variables x and y in it, this circle is lying on the xy plane, okay, not having any height along this z axis. Also the radius is 1. So this is actually x comma y. So 1, 0 is this point and this point is 0, 1. Okay. We do not consider the set coordinate. Fine. Now this is your curve. Now along this curve we have to integrate the given function xy. So let's see what this function is. Actually xy, by substituting each values for x and getting the corresponding y values, we get pairs of x and y, and from there we start drawing one curve, isn't it? So let this be the function f, which is xy. Okay. Now as I said, you have to drop lines from this function, and since it is given that we have to find the integral along this curve, let us drop the function, let us drop the lines from this function perpendicularly along this curve. Okay. Or it's just like a fence that we raise from this green color boundary. Okay. Just like constructing a wall like this, with the upper boundary as the function and lower boundary as the green curve. Anyway, so what we get by integrating this particular function, that is integral xy, we can have the integral like dx, or we can take it even as xy dy. Okay. So anyway, so in either way we get the area of this raised wall. Okay. So the basic idea is you must have only one variable inside this integral. Okay. So if it is a single integral, please make sure that inside the integrand, or the integrand does contain only one variable, either x or y. Okay. So let's put everything into equations. So that was the graphical explanation for the question. So now answering this, it is integral xy. We can take either dx or dy, it's your choice. So here I am taking dx. Okay. So since I have taken x, so I have to put the limits of the x coordinate. X coordinate here it is 0 and it ranges till 1. So 0 to 1 becomes my limits. And how to convert this y? As I said, you can only have one variable in one integral. Okay, so this integral 0 to 1 x into dx, I have to replace this y with a function in x. So for that replacement, I must seek help from this particular curve. Okay, so from this I have to get the equation for y, that is y square equal to 1 minus x square, or y is equal to root of 1 minus x square. Okay, actually this is plus or minus 1 minus root of 1 minus x square, but let me say you that we take only the positive side of the xy plane, isn't it? So we can have plus root of 1 minus x square, because we consider the first quadrant, isn't it? So it is like root of 1 minus x square. Now it became a normal integration, that is, I think by substitution method we can solve it out by simply putting 1 minus x square equal to u. What happens? How to replace this dx? It is just like minus 2x dx. How to take it? We have to differentiate all the LHS and RHS, that is derivative of 1 is 0 minus derivative of minus x square is minus 2x, and the differential coming here is change in x. This is equal to derivative of u is, or change in u. Okay, so x dx is actually du divided by negative 2. Okay, now it is integral root, what happens, 1 minus x square is now u, and x dx I replace it with du divided by negative 2, and after integration I will put on the limits. Why? Because here the term is in u, I mean the term here is u, so we cannot have 0 and 1 as the limits, because 0 and 1 are concerned to this x variable, isn't it? So what is this? Negative 1 by 2, u raised to half, integration is u raised to half plus 1 by 3 by 2, 2 cancel, it becomes negative 1 by 3, u raised to 3 by 2. Again I back substitute this u, that is negative 1 by 3. What is u? U is root 1 minus x square. So 1 minus x square in raised to 3 by 2 in the limits. Now I can put the variables, I mean the limits 0 to 1, because the equation has turned to x back. Continuing by putting the upper limit minus lower limit, that is negative 1 by 3 into 0 minus negative 1 by 3 into 1. So the answer is 1 by 3. So 1 by 3 is the area under that function f and the curve x square plus y square equal to 1. So hope that's clear about line integral. I think I will take double integral and triple integral problems in the next videos coming up. So hope this video about line integral is clear for you. If you like the video, please do like, share and subscribe it. Till we meet in the next class, this is Minu signing off. Thank you and take care.